When you think of the North Pole, you picture it frozen in place, forever anchored at the top of the world, unchanging and steadfast. Who could ever imagine the North Pole suddenly packing its bags and trading places with the South Pole? That would turn order upside down. Magnetic compasses would spin the wrong way. Maps would need to be redrawn from scratch. Flocks of birds, guided for ages by the Earth's field, would become wanderers lost in the sky. It all sounds like something from a sci-fi novel. Yet, geomagnetic reversals like these are real. They have happened before, not just stories made up in the dark. And the hidden truth behind them could be far more dangerous than anyone dares to imagine. The true terror isn't the moment of reversal, but the silent buildup that comes before. That's when our planet's magnetic armor, the shield against the sun's deadly rays, weakens, fading to just 10% of its usual strength. In 2021, some scientists warned of climate chaos, of waves of extinction sweeping the globe. Others pictured satellites roasted alive, global power grids blacking out, and lethal radiation pouring down upon us for hundreds, maybe thousands of years. This becomes all the more haunting when you realize we are already a couple 100,000 years overdue for the next reversal. And the strange tremors scientists now detect in Earth's magnetic field might just be the first whispers of that coming storm. So, should we be worried? Welcome back to this journey where we uncover the strangest secrets of our blue planet. Today, join me as we peel back the layers of mystery behind geomagnetic reversals. Will the next reversal mark the dawn of an apocalypse? Or will it simply leave a few lost birds wandering the skies? When everything goes south, what truly happens? Let's begin by searching for the origins of our invisible shield, the Earth's magnetic field. Don't be too quick to believe that every planet is wrapped in such a miraculous suit of armor. Our two neighbors, Mars and Venus, quietly spin through the cosmos without a single layer of protection. Only Earth is granted this special gift. Thanks to that magnetic cocoon, deadly solar radiation is held at bay, leaving the inner world free for life to rise, flourish, and break free from the shadows of extinction. Without it, every living cell would crumble beneath a rain of radiation. DNA would unravel. Mutations and cancers would creep into every corner of existence. Scientists remain restless, chasing the riddle of why some planets are armored with magnetic fields, while others stand bare against the storms of space. The most compelling theory whispers that deep within our planet's heart, the core acts as a mighty dynamo. It's a wondrous principle of physics. Electric fields beget magnetic fields. Magnetic fields birth electric ones, locked together in an endless, unseen dance. Even modern power plants borrow this magic. Move a magnet through a coil of copper wire and a current leaps to life. Electrons herded by invisible hands, swirling into the current's flow. In turn, the very motion of electrons conjures circles of magnetic field around them, all in accordance with Faraday's law, a spiral embrace between force and energy. But for this magic to unfold within Earth's core, everything must be exquisitely balanced, a symphony of matter and motion. The first condition: our core must be at least partly liquid, a place where movement can run free. Fortunately, above the solid inner core at our planet's heart, there lies a sea of molten metal. A liquid outer core where the pressure is not quite high enough to keep everything locked in place. The outer core of Earth blazes with unimaginable heat, soaring to 6,000 degrees Celsius at its hottest, a searing inferno to rival the surface of the sun, a hidden ocean of fire swirling beneath our feet. This intense heat, combined with lower pressure compared to the inner core, is more than enough to keep iron and nickel forever in motion, flowing and writhing deep below. As you journey outward from the planet's heart, the temperature drops, setting great cycles in motion. Hot, electrically conductive materials surge upward from the fiery depths, only to cool and sink again, endlessly looping in a mesmerizing dance. These churning currents are the birthplace of our planet's magnetic field. But if there are countless swirling loops down there, why does the Earth only have one North Pole and one South Pole? Why doesn't the magnetic field split and scatter in chaos? Scientists believe there is a hidden force at play, a secret hand gathering all the scattered fields, lining them up, pointing them in the same direction. This unifying power is called the Coriolis effect, a silent conductor bringing every spiral into harmony. According to dynamo theory, it is the Coriolis effect that takes those rivers of molten iron and gently twists them, making them spiral instead of simply rising and falling in straight lines. The Earth's rotation spins them into gigantic springs, each segment of every coil casting a circular magnetic field around itself. The combined result is that inside these massive springs, a unified, powerful field pushes upward as one, while outside, the magnetic energy loops back down, returning to the bottom of the coil. In short, this marvelous mechanism creates the familiar magnetic dipole, the North and South poles we rely on today. Yet, if there is one thing you should remember, it is how delicate this process truly is. The entire symphony depends on restless, sloshing seas of liquid iron. Hardly a stable foundation. That's why our magnetic field is always trembling, always wavering, shifting in subtle, unpredictable ways. One of the clearest signs, the North Magnetic Pole is never still, always quietly wandering, tracing out an endless journey across the face of our world. If you enjoyed this video, don't forget to like and subscribe for more fascinating stories. Since scientists first began charting its path in 1831, the North Magnetic Pole has quietly left its birthplace in Canada, wandering nearly 1,100 kilometers on a lonely journey towards the icy wilds of Siberia. Its pace has quickened, leaping from just 16 kilometers a year to nearly 55, a sudden, startling surge. Yet all this wandering is still little more than the fleeting wobble of a spinning top. Yes, it veers and sways, but always remains mostly upright, never toppling. A full reversal is something else entirely. And yet, scientists are certain that true geomagnetic flips have indeed happened before with astonishing precision. They count 183 reversals in the last 83 million years. But how do they know? The answer is etched deep within the Earth's surface, hidden in grains of iron. When magma erupts from the mantle, it brings with it molten iron, free to align itself with the planet's magnetic field. As the lava cools, those iron particles lock into place, forever pointing in the direction of the field at that moment. Scientists discovered that some ancient layers of rock are filled with iron pointing one way, and others where all the grains are turned exactly the opposite. There could only be one explanation. The entire magnetic pole had once flipped. On average, these geomagnetic flips seem to occur every 450,000 years, though the last few came only 300,000 years apart. And yet, it has now been 750,000 years since the last reversal, an interval so long that some believe we are already overdue. But the truth is far more mysterious, for scientists have found no pattern, no predictable rhythm to the timing of these reversals. There have been ages of silence between flips. The Cretaceous period saw one of the longest lulls, 40 million years without a single reversal. And the true record belongs to the Khayyam Reverse Super Chron, an era that stretched from 312 to 262 million years ago. A staggering 50 million years, with no flip at all. Scientists are still searching for what drives these colossal shifts. The current theory suggests that perhaps, in the deep shadows between mantle and core, some hidden interplay or collision sets off sudden turbulence in the core's spinning, breaking apart the spiraling currents that hold our magnetic order in place. When the Earth's magnetic field loses its unity, it unravels into chaos. A tangled web of clashing forces, with rogue poles rising and falling like rival kings fighting for the crown. In this tempest, several temporary poles might emerge, each vying for dominance amid the storm of magnetic confusion. Only after ages of turmoil do the spirals reassert themselves, bringing order once more. But which direction they choose seems a toss of cosmic dice, so about half the time, the magnetic North Pole reappears over the geographic South. This reorganization can take anywhere from 1,000 to 10,000 years. But does that truly mean the end of the world? The real danger lurks in the interim, for while order is lost, Earth's magnetic shield can wither to just 10% of its usual strength. In those vulnerable centuries, our planet is nearly naked before the solar storms. Auroras may sweep southward, painting strange lights across unfamiliar skies. But beneath that beauty, skin cancer would surge. Satellites would lose their protection, circuits frying under the cosmic assault, systems shutting down, and some machines slowly spiraling out of orbit, leaving the heavens littered with silent wreckage. Hit subscribe and like this video. Who knows, you might be the first to uncover stories never told before. Our electrical grid would become as delicate as a spider's web before the raging storms of the sun. One fierce blast could sweep away the lights of millions, leaving entire cities shrouded in darkness, powerless, cut off from satellites, the pulse of modern civilization silenced in an instant. It would be more than a shock. It could be a mortal wound for the world we've built. Yet things could grow even darker. A team of researchers from the University of New South Wales and Sydney revealed that even a temporary stagger of the Earth's magnetic field, not a full reversal, but an 800-year wobble like the Lachamp event, was enough to unleash mass extinctions across Australia, wiping out giants like Diprotodon, the hulking marsupial, and Procoptodon, the mighty kangaroo. These fleeting tremors, known as geomagnetic excursions, are not full reversals, and they often last just a few centuries, sometimes a mere 200 years, far too swift for nature to adjust. In their 2021 study, they uncovered dramatic spikes in atmospheric radiocarbon, evidence that the collapse of the magnetic field triggered climate upheaval, likely pushing those great creatures to extinction, and the timing, hauntingly, lines up all too well. But just how real are these risks? Honestly, it's a complicated picture. On the bright side, aside from this recent study, there's no real evidence that magnetic field reversals have ever gone hand in hand with mass extinction events. In fact, many reversals seem to have come and gone, leaving no mark at all on animal or plant life. And even within this study, the waves of extinction appeared only in certain regions. They made no claim of a global catastrophe. Elsewhere in the world, life moved on, untouched even during the Lachamp event. It seems a perfect storm of circumstances must have converged, leaving Australia uniquely exposed to the sun's radiation, while the rest of the globe stood sheltered. For our modern society, it's also worth remembering. These magnetic changes would unfold over many lifetimes. Even at their fastest, there would be time enough for humanity to adapt, to face a new reality, and make it our own. If our satellites aren't strong enough to withstand the coming storms, we would have time to craft new, stronger armor, upgrading our metal birds to brave the harshness of space. If solar radiation grows more menacing, we could adapt, staying indoors, inventing ever more powerful sunscreens, shields against the cancerous threat, perhaps even conquering it completely. And according to NASA, Even if our magnetic field were to fade dramatically, it's not as though we would be left utterly defenseless. Our atmosphere itself is a mighty shield, catching much of the radiation, protecting us from the solar wind and cosmic storms, at least for a while. It would take more than 10,000 years for our ozone to be stripped away completely. Still, I would expect at least some turmoil, moments of chaos as we adjusted to life beneath a weakened magnetic veil. Big changes always ache, always test the strength of society. And this isn't all hypothetical. Did you know that Earth's magnetic field has been steadily weakening for the past 200 years? It would take another 1,300 years for the field to vanish completely, so there is still plenty of time for this downward trend to reverse itself, for the Earth to right its course, and for all this to be nothing more than a temporary wobble. Yet there is another shadow we must not ignore: the South Atlantic anomaly, a growing wound in Earth's magnetic armor, stretching over South America and the surrounding oceans. This region might not touch life on the ground, but up above, it's fierce enough to fry satellites and put astronauts at risk. Even the Hubble telescope must turn itself off every time it passes through this dark zone, lest it be damaged beyond repair. Imagine that same vulnerability stretching across the entire globe. That's what we might face during a geomagnetic reversal. What's troubling is that the South Atlantic anomaly has been steadily expanding since scientists first began to watch it. Perhaps a warning sign that another geomagnetic excursion like the Lachamp event is near, or that a full-blown reversal has already quietly begun. If a reversal comes, it probably won't spell the end of civilization as we know it. But if the research about Australia's vanished megafauna is true, it certainly won't pass without scars. Some species may disappear forever, and humans will be forced to adapt to a world where the space beyond our sky is suddenly far more perilous. Learning about geomagnetic reversals and their hidden power is both fascinating and sobering. For most of us, we may never witness such a change, but for generations that follow, this may become much less hypothetical. They may see it unfold with their own eyes. Scientists spend years pouring time and energy into monitoring the health and safety of our planet's magnetic field. And for good reason. Out there, the universe keeps spinning, and even Earth's magnetic field can shift, upending the certainties we once believed unchanging. But no matter what the future brings, remember to listen to yourself, to keep your mind steady amid all of life's storms. Thank you for joining me on this journey into the mysteries of the magnetic field and the endless stories of humanity. If you have thoughts or questions about this topic, please share them in the comments below. I'd love to hear from you. Don't forget to like, share this video if you found it intriguing, and subscribe to the channel so you won't miss our next incredible adventures. Goodbye for now, and see you again on the Road of Wonder.